thank you for kind introduction. And as our chair mentioned, I instantly changed the title of my presentation. It was supposed to be anti-inflammatory, pro-resolving, and chemopreventive effect of docosahexaenoic acid and its metabolite. But I noticed that this international conference focuses on acupuncture and herbal medicine. So although docosahexaenoic acid, DHA, is the natural product, but it is not much used in the herbal medicine. That's why I changed the title. But still, I'm sorry, so those of you who attend this session because of this original title, then you can refer to our recently published paper in Redox Biology. I think this is it's a seminal article. You can learn about the pharmacological, especially cancer chemopreventive and anti-inflammatory effect of this particular compound. So with that, I'd like to start my lecture under this new title, which focus on herbs and spices with antioxidative, anti-inflammatory, and cancer therapeutic and preventive effects. As Professor Jigang Dong mentioned in his elegant keynote lecture this morning, the President Nixon, Richard Nixon, declared a war on cancer a day before Christmas Eve, December 23, 1971. So then he promised that the US people, Americans, will not worry about the cancer within 5 years. Okay? But as you know, this promise was not kept. So basically, the war on cancer turned out to be a failure. So now, 50 years later, I think remember that this the National Cancer Act was signed in 1971. Okay, 2 years ago, 2021, it celebrated 50 years. Okay, anniversary of Richard Nixon's war on cancer. And then I think that we have some consensus that we still is not a winner. So I wrote one, I think that there is something wrong. I don't know why. Okay, there should be some, let me see. Yeah, something's going, that's fine. Okay. Yes, so I wrote one editorial in the Journal of Cancer Prevention, for which I serve as editor-in-chief, the 50-year war on cancer revisited. So the question is, should we still continue to fight the cancer or not? And I think that we need some the strategy change. Okay, so I don't know why this PowerPoint become changed. Yeah. Anyway, we need a strategy change. The conventional strategy is to basically focus on the therapy treatment. Okay? But we have some kind of wonder drugs in these days, so-called molecular target-based therapies. But still, these miracle drugs are not much effective. They only prolong the survival of the patient to 1 or 2 years maximum. So in this context, we have to focus on another subject. This is the prevention. Okay? So the cancer miracle is not a cure, not a perfect treatment. It must be a prevention, as emphasized by Professor Dong this morning. So we have studied on many natural products, especially those present in our plant diet, including herbs and spices. And we are interested in some molecular mechanisms, especially cell signaling pathways modulated by these cancer chemopreventive agents. So I edited one book a few years ago with Professor Jigang Dong, published in CRC Press. The title was Dietary Modulation of Cell Signaling Pathways. I think people in this conference are interested in stress. Okay? But stress has two phases. There are good stress, we call the eustress, and bad stress, which is also called as distress. So stress has the kind of a Janus phase. So the question, too much stress is, of course, is not good. So it makes the people collapse. But if there is no stress, it is not good at all also. If, for students, they always have the stress because of the exam. I also experience them. But if there is no examination, they don't study. Okay. So, but that's the optimal level of stress is important. So we call this hormesis. Okay? Hormesis is the health benefit we can obtain from the mild or optimal stress. Many of the plant materials I mentioned, which have some health beneficial effect, they are basically poison, toxic. Okay? So they produce these chemicals, some chemicals, to defend themselves. So it is kind of a natural pesticide or biopesticide. We call this, more professional terminology, phytoalexin, okay, which is equivalent to plant toxin. So I mentioned that they are produced to protect plant themselves from insect, pest, and some other harsh environment such as UV. Okay? And however, at the subtoxic doses ingested by humans, okay, although they are very toxic to small animals or insects, so humans can tolerate. So when humans consume anyway this plant-derived poison, so we can tolerate, but nonetheless, these same phytochemicals may cause mild stress, although they are not lethal. So thereby inducing some adaptive cytoprotective response. So we humans take advantage of from using or ingesting these mild toxicant derived from plant. So I prefer to use this terminal 중용지도 in Korean pronunciation. I think this is similar to Chinese pronunciation. So moderate, okay? So amount of the stress is sometimes essential. So we are particularly interested in some anti-inflammatory plant-derived chemicals, phytochemicals. Why anti-inflammatory? Because inflammation is closely associated. I think that there's something wrong in the PowerPoint, which I said is not compatible. So some slides are not should not be included. Anyway, there should be some another title. Inflammation is closely associated with cancer. Now we know the 6 hallmarks of cancer defined by a famous oncologist, Dr. Robert Weinberg in MIT, and his longtime colleague, the Hana. But in these days, we also add one more hallmarks of cancer. This is the inflammatory microenvironment. One of the key components of inflammatory signaling is the enzyme called cyclooxygenase 2, abbreviated as COX-2. Okay? But interestingly enough, this inflammatory enzyme is somehow unregulated, overexpressed in many transformed cells and many different types of human cancer. So this suggests that COX-2 somehow has a role in carcinogenesis. So we know that aspirin is used in treat some symptoms associated with inflammation. So many scientists are interested in whether aspirin, which target the cyclooxygenase 2, can prevent cancer, especially colorectal cancer. So some doctors previously recommended to use of the frequent use of the small amount of aspirin to prevent cancer, especially colorectal cancer. However, there are some opposite opinions because daily use of aspirin may cause the side effect. We intake aspirin not on daily basis. We only intake this drug whenever we have some inflammatory symptom. So because of this, use of aspirin for the proposed cancer prevention is prohibited by some doctors. So there are still controversy about the use of aspirin in cancer prevention. I'm so sorry, this PowerPoint is not, I should have checked this before, okay? Yeah. So in this context, we have to look at some natural sources of anti-inflammatory agent. There are many natural products that may replace the aspirin, especially those used in traditional herbal medicine, including Ayurvedic medicine, India, Gampo medicine, Japan in medicine, traditional medicine, Chinese medicine, also Korean medicine as well. Especially the spices are interesting because spices contain many components which have a very powerful anti-inflammatory effect. Examples are curcumin present in turmeric and gingerol, pungent ingredient present in ginger, capsaicin in hot chili pepper, and some others. We have interested in this particular compound, curcumin, which is the yellow, responsible for yellow coloring of the curry. So we call the turmeric as an Indian spice, and the turmeric has been used for a long time in India in Ayurvedic medicine in the management of some pro-inflammatory disease. This is the quite old data published by WHO, but still interesting because this study compared the incidence of several cancers between India and the United States in both males and females. If you take a look at the data, among the tumors compared, the colorectal cancer, there are dramatic difference. In both males and females, the risk of colorectal cancer in India is much, much lower than that in United States. There are several reasons, including the religious reasons. People in India refrain from consuming the meat, especially red meat, which is the major risk factor of the colorectal cancer. But on top of that, people in India eat the curry on almost daily basis, which contain the curcumin. So the question is whether the curcumin in turmeric consumed by Indian people is responsible for low rate of the colorectal cancer. So to answer these questions, we started to do some laboratory studies. So curcumin and colorectal cancer, if there is there any link? Okay? And one inflammatory symptom which is responsible for colorectal cancer is inflammatory bowel disease, abbreviated as IBD. Okay? There are two types of IBD. One is the Crohn's disease, and the other one is ulcerative colitis. This morning, when the Professor Mi-Hyun Lee gave a lecture, and then the chair, Professor Na Chang-soo, asked how much proportion of IBD is responsible for colorectal cancer. Here is the answer. Okay? Nearly 40% of patients with ulcerative colitis develop colorectal cancer after 25 or 35 years later. There's one very simple and reliable animal model which mimic human inflammatory bowel disease. This is the so-called dextran sulfate sodium-induced colitis in mice. Okay? So when mice were given simply by this high molecular weight compound in 2.5% or 3% in drinking water, okay, they developed severe inflammation. As you see here, this is the normal mouse colon, but the mice which are fed dextran sulfate sodium DSS, you see the complete destruction of the colonic architecture. But when you give the mice with curcumin orally, the colonic architecture is also completely restored. And there's a severe body weight loss in mice given dextran sulfate sodium, but again, curcumin can nicely protect the body weight loss. But dextran sulfate sodium induced colitis is necessary, but not sufficient for the development of colorectal cancer. It must be initiated with a chemical carcinogen, azoxystrobin, AOM. So the single intraperitoneal injection of AOM, followed by inflammation caused by dextran sulfate sodium, give rise to the production of adenoma tumors and the adenocarcinoma, more aggressive type of the tumors, in just 10 weeks. Okay. So by utilizing this two-stage mouse colon model, we tested the cancer preventive effect of curcumin. So curcumin was given in two different doses, 0.1 millimole per kilogram body weight of mice, a higher dose, 0.25 millimole. And then we noticed that the curcumin administration inhibit the formation of azoxystrobin plus dextran sulfate sodium-induced colon cancer development. And we did some biochemical analysis. The tumors caused by AOM and DSS, I'm sorry, this is also replaced by, it should be a Western blot data, but I don't know why it is replaced by the morphological data. Anyway, the conclusion was that it should be curcumin administration inhibit the COX-2 expression induced by AOM plus DSS, whereas the COX-1 expression was not changed. Yeah, this is okay. So, and then the COX-2 expression is actually, maybe I think it should be better to use my laptop if I checked it earlier. Let me check. I think, yes, some other slides, okay. Okay, so the bottom line is that the COX-2 gene expression is mainly regulated by the transcription factor NF-kappa B. Okay, so NF-kappa B is present in the cytoplasm as an inactive complex with the inhibitory protein called I-kappa B alpha. Okay? So when I-kappa B alpha is phosphorylated, it undergoes proteasomal degradation. Then NF-kappa B, which consists of P50 and REL-A dimers, translocates to nucleus, where it binds to the promoter regions of pro-inflammatory genes, including COX-2. So we measure the NF-kappa B DNA binding by gel shift assay EMSA. We found that the tumor tissues in mice given AOM and DSS showed a very high levels of NF-kappa B DNA binding. And this was attenuated by curcumin administration, dose-dependent fashion. In addition to the two-stage mouse colon model, we also used the two-stage mouse skin carcinogenesis model. So according to this model, single topical application of carcinogen, such as again, this should be a chemical structure of a chemical carcinogen, but I don't know why. And the single topical application of carcinogen followed by repeated topical application of tumor promoter, phobal ester, we call TPA, derived from croton oil present in this particular medicinal plant, Euphorbia latiris. Okay? So it causes the inflammation, and combined with the carcinogen, it produces the skin tumors. And of course, skin tumors express high levels of COX-2. I think this is collapsed again. I don't know. So anyway, so we did one study by which this was done my first PhD student, Professor now Kyung-Soo Chun. He is the professor in College of Pharmacy in Kaemyung University. So he topically applied the mouse skin with curcumin prior to tumor promoter phobal ester. And we found that tumor promoter-induced COX-2 expression is inhibited in a dose-dependent fashion by topical application of curcumin. And this was associated with the suppression of NF-kappa B DNA binding. Okay? And I mentioned that I-kappa B alpha degradation is critical for NF-kappa B activation, and tumor promoters stimulate the degradation of this inhibitory protein I-kappa B alpha, and this was also attenuated by topical application of curcumin. NF-kappa B is important transcription factor in inflammatory signaling and also oxidative stress. Okay? So oxidative stress induced by reactive oxygen species can stimulate the inflammatory signaling, and inflammation also induces the oxidative stress. So there's some kind of vicious cycle. But we have another important transcription factor which counteract the pro-inflammatory action of NF-kappa B. This is the transcription factor called NRF2, NRF2. I saw several presentations during this conference which studied the NRF2. So we found that Dr. Kyung-Soo Chun also found that NRF2 is the important target of chemo prevention of skin carcinogenesis. And one target of NRF2 is the antioxidant and anti-inflammatory enzyme called hemoxinase 1, H1. H1 degrades the heme as a substrate to produce bilirubin, which is further converted to bilirubin. So bilirubin is the kind of the ROS scavenger. Okay? So it's the natural antioxidant. So we found that topical application of curcumin induces the hemoxinase 1 in a time-dependent fashion, and this was associated with induction of NRF2 and its DNA binding. And when we utilized the NRF2 knockout mice, the embryo fibroblast from NRF2 knockout mice compared with that from wild-type mice did not express any hemoxinase 1 when treated with curcumin. Here we have a very strong induction of hemoxinase 1 in wild-type embryo fibroblast, but NRF2 knockout mice did not, indicating that curcumin-induced hemoxinase 1 is mediated by NRF2 activation. NRF2 is normally present in the cytoplasm as an inactive complex called KEAP1. Okay? Like a majority of proteins, NRF2 is a synthesized and unused part is degraded by ubiquitination and proteasomal degradation. When there is oxidative stress or electrophilic stress, some cysteine sire present in KEAP1 is oxidized or covalently modified. This diminishes the affinity of NRF2 for KEAP1, releasing NRF2. Alternatively, ROS and electrophile stimulate the phosphorylation of NRF2, which also facilitate the nuclear translocation. So we are interested in how curcumin can activate the NRF2. Because curcumin has two alpha-beta unsaturated carbonyl group, it acts as an electrophile. Okay? So it can covalently modify with some cysteine sire present in KEAP1. And this leads to the stimulation of the dissociation of NRF2 from KEAP1. So we did a mass spectral analysis of the KEAP1 protein treated work with curcumin, and we found that cysteine 151 present in KEAP1 protein is covalently modified curcumin. So this is responsible for mechanism in which the curcumin activate the NRF2. There is one interesting medicinal plant, Alpinia oxyphila in Korean ikjin. It also belongs to ginger family. Okay, and this medicinal plant, some compound, its structure is somehow similar to curcumin. We also found that this diaryl heptanoid from Alpinia oxyphila also inhibit mouse skin tumor promotion by suppressing COX-2. Ginger, also Dr. Dong this morning briefly mentioned, it has strong anti-inflammatory activity. It is used currently to alleviate some inflammatory symptom and also vomiting. Okay, so when we have a flu, okay, so then our mothers often give the ginger tea because it has some anti-inflammatory effect like aspirin. So ginger contains several pungent ingredients, including gingerol, sugar, and gingerol. Okay. Previous studies in my laboratory demonstrate that 6-gingerol, when topically applied onto mouse skin, inhibit the inflammation and tumor promotion. And 6-gingerol inhibit the COX-2 expression by blocking NF-kappa B signaling. And also gingerol, and is another pungent ingredient, 6-paradol in ginger, induces the apoptosis in human leukemia cell line. Dr. Dong published a paper in Cancer Research long time ago, which demonstrate that inhibitory effect of 6-gingerol on epidermal growth factor-induced cancer cell transformation by inhibiting activator protein 1 activation. Let me switch the gear to another pungent ingredient present in hot chili pepper. This is capsaicin, which is currently used as an ointment, okay, to treat some painful symptoms such as the diabetes, neuropathy, and others. And I'm sorry, this is another wrong slide. So we published that the capsaicin induces the apoptosis in cancer cells like pungent ingredient ginger. Okay, so now we know the pharmacological action of capsaicin is mediated by particular receptor. Okay? So this receptor was discovered in 1997, okay, according to this Nature paper. And this receptor responds to several different types of chili pepper. Because the more, I think, the pungent ingredient, such as the capsaicin, activate the receptor, whereas there are not much pungent peppers like this wax, it is not much stimulating the capsaicin receptor. Okay? And when some of our American or European friends eat hot chili pepper in Korean barbecue restaurant, so they always say it's hot. Okay? Why hot? Hot is the word to express the temperature, right? Yeah. So we have another the word to express the pungency, pungent. Okay? So, but this is kind of natural response. They feel the pungency like a hot temperature. But this is the scientifically proven. When the authors of this Nature paper led by David Julius in University of California at San Francisco, they found that this capsaicin receptor respond to not only capsaicin, also chili pepper, but also hot temperature, mechanical stress. That's why people say it's hot. It's the same. Okay? The pungency and the high temperature are recognized by the same receptor. And because of this discovery, the David Julius received a Nobel Prize a couple of years ago. Mm-hmm. And the capsaicin the receptor knockout mice, they don't feel the pungent. Okay? So they enjoy drinking the water which contain the capsaicin. Okay? And then now we call this the capsaicin receptor transient receptor potential type vanilloid 1. Long name, so abbreviated as TRPV. There are several different types of TRPV, but TRPV1 is the capsaicin receptor. We call this vanilloid receptor. Why vanilloid? Because of chemical structure. So this is capsaicin and some capsaicin analogs, for the chili pepper, or some ginger also contains the pungent ingredient. They all have the same moiety here. This is the vanillin ring moiety. The ice cream vanilla contains the vanillin, which also contains this structure. But because of the other part, the hot chili pepper and ginger has a pungency. So the capsaicin receptor TRPV1 have many interesting physiological and pharmacological properties. So emerging role of TRPV1 in diabetes and obesity. So obese people express much lower levels of TRPV1, okay, compared with lean people. So this suggests that TRPV1 as well as capsaicin play a role in I think probably weight loss. Here, interestingly, capsaicin, when given to normal mice, it did not much affect the body weight. But when given to obese mice, fed the high-fat diet, capsaicin reduced the body weight. And recently, TRPV1 has been suggested as, to be responsible for longevity. And this is due to the action of capsaicin receptor TRPV1, which may help prevent metabolic decline with age in elderly people and lead to increased longevity in humans. TRPV1, basically, as I mentioned earlier, is the ion channel. Okay? But the problem is the capsaicin is very irritating and pungent, so which limit its use as pharmaceuticals or cosmeceuticals. But fortunately, there is some capsaicin analog, which is not pungent, derived from sweet pepper. Okay? I don't know sweet pepper is real pepper. Anyway, this sweet pepper contains one chemical which is not pungent compared with capsaicin. If you take a chemical structure, almost the same, except this atom. The nitrogen in capsaicin is replaced by oxygen. Okay? Because this single atom replacement, the pungency in capsaicin is completely abolished. So there is the beauty of chemistry here. So with regard to role of the capsaicin or hot chili pepper in human cancer, some people think capsaicin or chili pepper are carcinogenic or co-carcinogenic. Others think it is cancer preventive. Okay. To prove this, we did some small, simple animal study, two-stage mouse skin carcinogen model we employed. So what we tried to do was that we initiate the skin carcinogenesis with single topical application of chemical carcinogen, DMBA. Then we repeatedly treat the mouse skin with capsaicin, okay? And to see whether this capsaicin treatment can increase the development of skin cancer. But we noticed that capsaicin, when repeatedly applied onto mouse skin, did not increase the skin tumor formation compared to control. Okay? But on the contrary, capsaicin pre-treatment before the non-tumor promoter phospholester inhibit the DMBA plus TPA-induced skin carcinogenic, suggesting that capsaicin, at least in mouse skin carcinogen model, act as an anti-tumor promoting agent, and this was associated with its suppression of tumor promoter-induced NF-kappa B DNA binding. And Dr. Dong and his colleagues published a paper in Cancer Research. The capsaicin receptor, TRPV1, has tumor suppressive function because TRPV1 knockout mice are more susceptible to skin tumor formation. Okay. But later, Dr. Dong and his colleagues also found that the capsaicin can act as co-carcinogen depending on the dose. And so, but this co-carcinogen effect of capsaicin is not related to its activation of TRPV1, but it is related to oncogenic signal, EGFR signaling. So in this context, capsaicin has dual effect. It can be a friend or a foe. But then the question, Korean people consumes the hot chili pepper. Maybe I think the most amount in the world. Okay? So, but we still enjoy from our ancestor. But I don't think capsaicin or hot chili pepper is not carcinogen. Otherwise, we already stopped making kimchi. So I think the capsaicin in the ordinary amount we consume as part of our Korean the signature diet is not carcinogenic. Of course, if we eat too much, okay, like other chemicals, it can be a poison. So finally, I think for the interest time, I'd like to wrap up my presentation. Besides the spice, of course, we have many herbs which have a cancer preventive, and this is really, really interesting. Why there is the photo of my former research professor. This should be the chemical structure or of this plant. So this program automatically, I think, changed everything. So this is the Artemis asiatica medicinal plant containing this flavonoid eupatilin. Okay? And this medicinal plant has been used long time in traditional Asian medicine, especially in the treatment of several inflammatory disorders. Okay? And this is actually on the clinical application for the treatment of inflammatory and oxidative gastric damage. Okay, this is my recent PhD student, very interesting. So this Artemisia asiatica now used as part of the medication. One of the pharmaceutical company, Korea Dongha pharmaceutical company, recently the owner passed away a couple of days ago, and they produced one formulation, the Stilen. Okay, this is kind of the bestseller drug, and which treats some gastric problem, especially inflammatory symptoms in the stomach. We found that the standardized extract of this medicinal plant, DA stands for the Dongha pharmaceutical company of this medicinal plant, inhibit the azoxymethane plus dextran sulfate sodium promoted mouse skin colon carcinogenesis. This photo should be replaced by my paper, which demonstrates the preventive effect of the DA formulation from Artemis asiatica on two-stage mouse skin carcinogenesis. Finally, we also found that eupatilin, the major ingredient of this medicinal plant, Artemisia asiatica, induces the apoptosis in human promised leukemia cells and arrest the cancer cell progression. And its analog, another compound, also has the pro-apoptotic and cell cycle arresting effect. Okay, so this is the final slide, my conclusion slide. Cancer is the result of a divorce from nature. So we humans have a very close association, relationship with our nature, especially the Mother Nature, which provides a whole variety of very good, I think, the gift, especially medicinal, the herbs and spices, which contain the anti-inflammatory, antioxidative, cancer preventive, and other health beneficial activities. Okay, so these are people, my former and recent people in the lab, and one day, long time ago in homecoming, they were gathered. But here, Professor Miyeon Lee, he's one of the organizers of this conference in Dongsin University College of Korean Medicine. She was my former PhD student, but at that time she was in US in Dr. Jigang Dong's lab as a postdoc. Okay, and now Dr. Dong released Professor Lee okay, to this university. So this year in May, we had a conference we called the NAPA, Nutrition and Physical Activity Conference, which I established. We had a meeting in May, and at that time, Dr. Dong attended. So Dr. Miyeon Lee kindly sent me this memorable photo this afternoon, so I include this one. I'm very happy this photo is not collapsed. Okay, with that, I'd like to finish my presentation. Thank you for your kind attention.